Hi guys, this is Teacher Metra. Well, how was your Hari Raya? I'm sure you have gala time, eating and drinking all kinds of food. Well, today's lesson 27, is about neutralization. This is a very important subject because neutralization is an act to stabilize things, whether they are food or drinks, or for that matter your body. So even if you're going to shampoo your hair, right, you need to neutralize it so that your hair looks brilliant. So this is a very important subject for us to learn, so that we can take care of ourselves scientifically and using the simple law of neutralization. So lesson 27, neutralization, will cover various factors. So in this lesson you will learn what is neutralization is all about, and what are the applications of neutralization in daily life, and then you will learn something new, and what we call acid-base titration. So what is acid-base titration? Number 4, and how do you determine the end point of an acid-base titration? What do you mean by end point of acid-base titration? So the keyword here is end point. Now you will learn about that later. Then number 5, how numerical problems involving neutralization reactions are solved. So these are the things that you will learn, and you will apply it so that it is beneficial to you and to your family members. So now, what is neutralization? Now the word is from the word neutral, and then sation, making it neutral. That's what it is. So neutral is to change things from one state to a more ideal, stable state. So that is what neutralization is about. So what is neutralization? Neutralization is an action between an acid and a base to produce only salt and water. This is what is called neutralization. So this is just a chemistry term of explaining what neutralization is, right? So in chemistry, when we talk about neutralization, we are talking about the reaction between an acid and a base to produce only salt and water. So that is what neutralization in chemistry means. But at the same time, this acid base also relate to your body and relate to our life. So somehow or other, you will get involved in your day-to-day living with neutralization in many other forms. And in a neutralization reaction, what happens is the hydrogen ions of the acids react with the hydroxide ions of the alkali to form water molecules. So we can say neutralization happens when the hydrogen ions of the acids react with the hydrogen ions of the alkali to form water molecules. So example, if we look at this equation, hydrogen ions, the H plus aqueous, plus OH negative, the hydroxide ion, aqueous, will react and form a water molecule, H2O, in liquid form. So this is what it means. So when we talk about neutralization, we are talking about the hydrogen ions, H plus, in aqueous state, plus the hydroxide ion, which is the OH negative, also in aqueous state, and will react. When they get together, they will form a water molecule, that is H2O liquid. So this is what neutralization is all about. Now, examples of neutralization reactions. You can see here there are a few that we will bring to the fore, and you will observe the chemical reaction and then the ionic equation of the neutralization reaction between acids and bases or alkalis. The first one, it is sulfuric acid plus potassium hydroxide. So this is an acid and alkali. So what happened is, the chemical reaction H2SO4, which is the sulfuric acid, plus 2 KOH, that is the potassium hydroxide, 2 potassium hydroxide in aqueous form, will react to form K2SO4 and 2H2O. So it will form what we call the potassium sulfate, the salt, and 2H2O molecule. So if you look clearly at this equation, you will notice that the potassium hydroxide have taken place the hydrogen ions. The H2 is now being replaced by K2. So whenever an H is being replaced with another metal, they become salt. So now from H2SO4, that is the sulfuric acid, has been converted into potassium sulfate, and they produce 2 H2O molecules. So this equation shows you that when sulfuric acid react with potassium hydroxide, it will produce potassium sulfate and 2 water molecule, 2 H2Os. Then the ionic equation is the standard hydrogen aqueous when mixed with OH negative, the hydrogen hydroxide rather, the reaction will produce water molecule H2O. So that is the first neutralizing reaction. Now the second one, nitric acid plus calcium hydroxide. So when you look at this, can you write a chemical formula for this? Nitric acid plus calcium hydroxide. What is the formula for nitric acid? Is it HNO3? That is nitric acid. What about calcium hydroxide? CaOH2, right? So 2HNO3 aqueous plus CaOH2 aqueous will react and produce CaNO3 2 aqueous and 2H2Os. Again, you will look at 2H will be taken away and replaced by the calcium ions. So when the calcium ion take over the 2H, it becomes a salt. And then this equation, if you look, you know CaOH2, meaning this calcium hydroxide requires 2 electrons. So I beg your pardon, it requires 2 two substances to bond. So now they have this, they need this two hydrogen from the nitric acid. So it will form the water molecule. 2H plus 2OH will make 2 H2Os, and then the calcium will join up with the nitric acid and become calcium nitrate. And the ionic equation is still the same. The hydrogen ion H plus aqueous plus the hydroxide ion OH negative will always react and produce water H2O. So nitric acid, when you mix with calcium hydroxide, will react to produce calcium nitrate, two of them, plus 2 H2O. Now the third one here is the most common acid, the hydrochloric acid plus sodium hydroxide. So whenever hydrochloric acid meet with sodium hydroxide, what will happen, do you think? So they will convert the acid into salt. So here you will see HCl aqueous, which is the hydrochloric acid. When they meet NaOH, the sodium hydroxide, right, they will react to produce sodium chloride aqueous and H2O plus H2O liquid. So this is 1 against 1, hydrogen plus 1 natrium. So 1 hydrogen plus 1 natrium will give you sodium chloride, and then the Cl will join up with the 1 Cl will join up with the sodium to form sodium chloride, and the 1 H will join with the OH to make one water molecule. So again, the ionic equation is hydrogen ions plus the hydroxide ion will always react to produce a water, a liquid form. So these are some of the examples of neutralization reaction that we will encounter every day, right? It also happen not only outside in the lab, it also happen in our body. So understanding this will make sure you keep your body fit and firm. You won't be flabby or being obese, right? So neutralization is a reaction between an acid and a base to produce only salt and water. Neutralization can be carried out by using a method called acid-base titration. Now this is done simply to prove that neutralization do takes place between an acid and a base. So how much acid will require certain amount of base, certain amount of acid will require certain amount of base, to react to convert and make it neutral. So this can be done in the lab using a technique called acid-base titration. That is just to prove a point. So even without titration, your body should be able to perform the same function if you put in your body the appropriate food. Taking acidic food without any alkali food will make your body imbalance. So that's the reason why when you need to eat food, you need to take, even if you take meat, you have to take vegetables, you have to take fruits, you have to take water. You need to balance everything. But if you take meat and meat and meat without any vegetables and all that, then you are becoming extreme. So then your body will be excess of acid. So when your body is in excess of acid, and if acid cannot be get rid of, if it's not converted, it can only be converted either in a form of water or in a form of salt. But when you don't have enough stuff to convert these hydrogen ions into salt and water, then it accumulates in your body and it makes your body weak, and you may be big but big sideways. which is not very healthy. So for people who are obese, they have this problem. So they need to learn neutralization so that they can reform back their body to its original configuration. Nice, sleek, and pretty, not flabby and rounded sideways. There are people who look like pears and there are people who look like apples. So we don't want that. Right? So the application of neutralization in our daily life can be very, very useful and save time and a lot of pain. For example, a red ant sting or a bee sting. If a red ant sting and a bee sting, you will feel initial pain, but later it becomes itchy. So if that's the case, then you know that these are acidic, these stings are acidic. So all you need to do is you treat them with baking powder, that is sodium hydrogen carbonate. Unless your mom bake bread or bake cakes, you may find this baking powder in the shelf. Otherwise, then you don't have the baking powder, right? So the sodium hydrogen carbonate or the baking powder is also known as NaCO3. These are bases, and it neutralizes the acidic stings. So when you have this kind of stings, just apply the sodium bicarbonate or the sodium hydrogen carbonate, and you have solved the problem. You don't have to suffer the pain and get irritated by the itchiness, right? On the other hand, if you get a wasp sting, that is alkaline, and alkaline sting normally give you a burning sensation. So when you have that kind of burning sensation, and all you need to do is just look for vinegar. Yeah, in your kitchen, that vinegar, also known as ethanoic acid, that is the CH3COOH. So just apply that vinegar onto the sting, and here, bingo, all the pain will be gone in a matter of seconds. So these are what we call neutralization. So when the sting is alkali, you treat with acid. When the sting is acidic, you treat with alkali stuff. So by doing this, you revert everything back to its original form. So how important this neutralization is. Only if you know how to apply it in your daily life, then neutralization will not mean anything much to you, right? Now another factor here is excess acid in the stomach causes indigestion and gastric pain. So I'm sure during this Hari Raya, many people will encounter all kinds of stomach aches, Well, some will be running to the toilet, Some will be, yelling, aching, Some will be, unease with all the indigestion. So what normally they will do? Well, they will go to the provision shop or 7-Eleven or any pharmacy and try to get the Eno. Eno is a salt. It's a fruit salt, and that is alkali. So when you take the Eno salt and pour some water and drink right away, then it will go into your body and try and neutralize the acid. So then it depends on the quantity of acid in your stomach. If you got plenty of acid, you need plenty more of alkaline salt to neutralize it. So it doesn't mean when you have stomach ache, just taking one packet of Eno is good enough. Sometimes you may even need more. But then, how much does it cost? But better still, just get some young ginger, pound them, add some hot water, let it simmer, then drink the young ginger juice, because young ginger juice is alkali, so it will serve the same purpose. It will neutralize the acid in your stomach. But if you need to go to the clinic, of course the doctor will treat you with magnesium hydroxide. They have some medication which contains only magnesium hydroxide, MgOH2. So then it will go and relieve your pain. So excess acid in the stomach causes indigestion and gastric pain. So the medicine for treating gastric pain contains weak acid bases such as magnesium hydroxide, MgOH2, or sodium hydrogen carbonate, the NaHCO3, so that the excess acid in the stomach is neutralized. So you can take this chemical, or you can take a young ginger, pound them, put some hot water and drink that water. So the more pain you have, the more ginger you should take. You need to balance them, the whole thing, and by doing so you may relieve yourself of all the pain and sufferings, right? Now another factor is soil, which is acidic. It's not suitable to grow crops. You may plant anything, but it just refuses to grow. If at all it grows, it will be very weak, and in no time the root will be rotten, will get rotten, and the tree will die off, or the plant will die off. So for farmers, if they want to grow crops commercially, they need to do the first thing first, that is to neutralize the land before planting. So they are aware that acidic soil is not conducive for planting, so all they need to do is just plow the land and add lime to it, the slaked lime, which is the cheapest form of alkali, the CaOH2. So they apply the lime and let it settle for a couple of days, then only they will start planting. So you need to neutralize the soil. Likewise, when people try to rear fish in a pond, you just cannot dig a pond, use an excavator to dig a pond and just pour water inside there and put some fish. Your fish will die for sure, because the soil are all acidic. So all you need to do, you dig the pond first, right? Then treat the pond with the slaked lime. So maybe 48 hours or 72 hours. Only then will you run in the water into the pond. Then you let it settle for another week. Then only you can put all your fish fry or your fish, so that they won't die. So understanding neutralization is beneficial for us to gain in our economic activities. Otherwise, we will just do the hard work and encounter big losses when you don't understand how to utilize the neutralization factor in whatever you are doing. So can you imagine the importance of understanding of this neutralization in our daily life? Another factor is acids are produced by bacteria. So when they feed on food residues in between your teeth. So after dinner, you just lie down and fall asleep. So while some residues of the food still get stuck between your teeth, so the bacteria will work on it and they will produce the acid. Now this acid causes tooth decay, and if they are not neutralized, your teeth will be turned into decayed tooth, and it looks ugly and it gives off a horrible smell. Therefore, if you want to protect your teeth, make sure before you go to bed, just brush your teeth, because your toothpaste will contain the magnesium hydroxide, which will neutralize the acids in your mouth before you go to bed. So there won't be any bacteria working on the food residues, because you have brushed your teeth off. And then since there is no residue food in between your teeth, there won't be any bacteria working on it. Therefore, your tooth is protected from decay. So make sure before you go to bed, brush your teeth. Now another thing is shampoo. Shampoo is usually slightly alkaline. So after using your shampoo, you know, some of the residue shampoo that remains between your hair makes your hair looks dull and coarse. So then you will be suggested to use hair conditioner which is actually acidic, so that it will neutralize the excess shampoo and make your hair look shiny. So after shampooing, then all of a sudden you find you are run out of conditioner. What would you do then? Well, just go to the kitchen, look for your vinegar, just take a few drops of that vinegar, right, and then add a little water to it, then just run over your hair, so they will act just as good as the hair conditioner that you're gonna buy from your pharmacy or from your 7-Eleven. So see, the vinegar is so handy to be at home. It can treat stings. It can also treat your hair and make your hair shiny, right? Then of course, obesity is a sign of an acidic body. As I said, too much meat will make you fat. You know why? Because meat contains a lot of acids. Because meat are protein are made of amino acids. So amino acids, so the residue are all acids. So if these acids are not being neutralized by alkali or by bases, by vinegar, by onions, by vegetables, by fruits, then they will keep accumulating in your body, and the spent energy is just left there to be seen, and you can show your excess fat, you know, to everybody. That shows your inability to neutralize all the acid. So when you meet a fat boy or a fat girl, it simply means that they did not neutralize the acid from their body. So as time goes by, they will get bigger and bigger, but the worst thing is they will have a weaker bones, because calcium will be taken from their bones to help the body neutralize all the excess acid. Then when they take calcium from the bone, now the calcium is becoming weaker, and then they will have all the so-called joint pains, knee pains and whatnot. So do your body a favor, right? If you do have to take a lot of meat, at the same time enjoy that meat and complement the food that you take with vegetables, and fruits. Do that a lot. Now it will help you, make you enjoy your life, at the same time doesn't burden the body, and you will be healthy all the while. So eating is not the real problem. It is the neutralization, the balancing of your diet, that is very, very important. Now we come to the acid-base titration. So what is acid-base titration? So number one, when an acid completely neutralizes an alkali, all the hydrogen ions in the acid and the hydroxide ions in the alkali combine to form water, right? So that is what neutralization is all about. So neutralization is complete when an acid completely neutralizes an alkali. All the hydrogen ions in the acid and the hydroxide ions in the alkali combine to form water. But here, when you look at this statement, we say that when an acid completely neutralizes an alkali. So why do you need an acid to neutralize an alkali? So we do this if your body is full of alkali substance, then you need acid to neutralize it. But since your body is full of acid substance or acidic substance, then you need an alkali substance to neutralize it. So it can be either way around, right? So we can do this experiment by conducting an experiment called an acid-base titration to see the effects of neutralization. So the products of complete neutralization are only salt and water, which are neutral with a pH of a value of 7. So look at the word neutral, meaning it make all the extreme stuff becoming harmless. So when you are so extreme, your body is so extreme in acid, so when you neutralize it, it will return back to a condition called neutral. So that is what our body should always be. In fact, our blood should be in a form of slightly alkali, 7.2 or 7.3. That's the maximum. It cannot be too high. It's a very slight alkali. But for function, you need acid, because you need the acid to break down all your food. But your blood need to be alkali. So you see the balancing required here, right? So to show that neutralization reaction has completed, an acid-base indicator is usually used. When a neutral solution is formed, the indicator changes its color, indicating the completion of neutralization reaction. So in a lab, to know that the neutralization is completed, we need some indication. So how do we know that it has been neutralized? So we'll use an indicator. So this indicator will give you a particular color. So when the moment you add the opposite substance, if it's alkali, you add acid. If it's acidic, you add alkali. So the moment it reaches an end point, meaning it reaches a point where the total hydroxide ion or the hydrogen ion are completely converted into water. So there is no more hydrogen ion and there is no more hydroxide ion. So that is when we call the end point. You reaches the end point, and at that point the pH value is always 7 for the solution. Number 4, an acid-base titration is a quantitative experimental technique used to determine the volume of an acid required to neutralize a fixed volume of alkali with the help of an acid-base indicator. So in acid-base titration, it's a technique, a quantitative experimental technique used to determine the volume. You need to use this to understand, to know how much is the volume of an acid required to neutralize fixed volume of an alkali, and vice versa. And you will understand this. You will see the changes, the neutralization effect, with the help of an acid-base indicator. Do you remember I asked you to do the indicator using the red cabbage? That is what we call an indicator. So if you're going to use the indicator, and if the indicator you pour a few drops of indicator into an alkali solution, it is bluish in color, blue in color. So when you put the acid, then it will change into green. So you can see the difference there, right? Now if you're gonna put the same indicator into an acidic solution, it will be orange or red. Then when you add the alkali to neutralize it, eventually it will also turn to green. That means the total neutralization have been completed. Meaning they have reached the end point. You need that indicator to let you know the point reached or otherwise. So in an acid-base titration, to do a quantitative experimental technique using fixed volume, you need certain apparatus. And here I show you an apparatus called a pipe. This pipe normally contains about 25 cm cubic centimeter of liquid. It can be anything. It can be acid, it can be alkali. So you need this PP, you need a Bure. So this Bure will also apply. It contains certain amount of fixed amount. So using both this amount, you know how much of acid is utilized to neutralize a certain amount of alkali. So for example, you put an acid into the PP that is 25 cm of cubic cm of liquid or acid. Now you put into the beaker, but before you put in the beaker the acid, you just add the a few drops of indicator first. Then when you use the Bure, which is filled with the hydroxide or solution, you drop to see until it changes the color, then you stop. So these are the things that you need to use. But in a proper experiment, you need to have your retort stand and whatnot, so that you can. This is just to show you what are the apparatus that you require to do an acid-base titration. So in an acid-base titration, usually an acid from a Bure is added into a conical flask, which contain a known volume of alkali. So in other words, the conical flask contains the alkali substance, and the acidic acid is in the Bure, so they will drop. So the exact volume of alkali is accurately measured by a PP. So you need to put certain amount, use exactly the amount, so that you'll get the proper readings. So in an acid-base titration, usually an acid from Bure is added into a conical flask, which contain volume of an alkali. So the exact volume of alkali is accurately measured by a PP. So the alkali is usually colored by 2 to 3 drops of a soluble indicator before the addition of the acid. So make sure you do that first. Then the acid is stopped from flowing into the conical flask at the end point. Here again at the end point, when the indicator changes color, indicating the pH of the neutral solution has been produced. So this is what apparatus you will use: a Bure, which contains the acid, and then the conical flask that contains the alkali. So both of these have fixed volume. So from this fixed volume, you will determine how much acid is required to neutralize that much of alkali, and vice versa. Then the end point of titration is the point at which the acid-base indicator changes color. So the titration is said to have reached the end point, that is the neutral point, indicating all the hydroxide ions has been neutralized by hydrogen ions to produce a neutral solution. So the end point here, normally it requires some time, and then upon retrieving that time, it will change color. So when it changes color, it is definitely have a pH value of 7. That is what neutralization is all about. So you will keep on dropping and drop the acid into the alkali solution until such time it changes color. So the moment it changes the color, it is for sure you have reached the end time, and that end time will show a pH value of 7. Now it will require a certain amount of time, so it depends on the volume. Certain volume will require a shorter time, another volume will require a longer time, but yet they will reach the same destination. So indicators which are commonly used in an acid-base titration are phenolphthalein and methylaurine. These are the common ones you find in the lab. And but in acid-base indicator, a pH meter is usually used in titration. Instead of acid-base indicator, a pH meter is usually used in titration. Now that is to be more exact. So the pH meter records the changes in the pH value during neutralization reaction, which is then fed into the computer to plot the curve, and the pH curve like the one above, right? So determination of endpoint of acid-base titration and the concentration of hydrochloric acid. So the aim of this activity is to determine the endpoint of acid-base titration between hydrochloric acid and sodium hydroxide, and hence the concentration of hydrochloric acid. So the apparatus, you need a pipe, you need a pipe filter, you need a retort stand, you need and clamp, and a white tile, a beaker, a bure, a filter funnel, 250 cubic centimeter of conical flask. So you see, everything is a fixed amount, fixed volume. So this is how you set up your experiment. You have a retort stand, you know, with a clamp, and that's how the bure down there with the fixed amount of hydrochloric acid solution, or then you have the fixed amount of sodium hydroxide solution in the conical flask. So when you put a fixed amount there from the volume that acid that you use, you will know for sure what is the quantity of acid required to solve or to neutralize this quantity of alkali. And of course you need a white clay so that it will reflect the color change effectively. Without that, you may find difficult to look at the color changes. So the materials used is 200 cubic centimeter of 0.1 mole per cubic decimeter of aqueous sodium hydroxide solution, then hydrochloric acid and phenolphthalein indicators. These are the things that you will use. Then the procedure. Number one, of course, a clean pipe is filled with 25 cubic centimeter of standard sodium hydroxide solution with concentration of 0.1 mole per cubic decimeter using a pipe filler. So you have to use that to get the measurement. Then the sodium hydroxide solution is transferred into a conical flask, and 2 or 3 drops of phenolphthalein are added, and the mixture is shaken well, and it turns pink. The conical flask is put on top of a white tile. So this is the procedure you have to follow. Then a clean bure is filled with hydrochloric acid, and the bure reading is recorded as Y1 per cubic centimeter. Then hydrochloric acid from the bure is released slowly into the titration flask or the conical flask, and the titration flask is swirled gently and constantly to mix the content. Just swirl them gently. Now, as soon as the solution in the titration flask turns from pink to colorless, the addition of the acid is stopped immediately. The final bure reading is recorded as X1 cubic centimeter. Now, number 6, step 1 to 5 is repeated, but the hydrochloric acid is added drop by drop near 0.3 to 0.5 cubic centimeter to the endpoint of titration to get a more accurate volume of the hydrochloric acid added. You have to do it carefully, so drop by drop until you reach the endpoint of the titration. Then you get your readings. Number 7, the titration is repeated twice, and the average volume of the hydrochloric and acid added to neutralize completely 25 cubic centimeter of 0.1 mole of per cubic decimeter of sodium hydroxide is obtained. So you need to do this 3 times. Then you get the average reading from all the 3 experiments. Then you will tabulate the data. So you will do your data in this manner. row 1 you have the titration number, the burette reading, number 1, number 2, number 3, and then the column 1 is the final reading in cubic centimeter, the initial reading in cubic centimeter, then the volume of hydrochloric acid added. Then from here you can see at titration number 1 you will get your x1, then the initial reading is y1. Then to get how much volume of hydrochloric acid, you just take x1 minus y1, then you get the v1. So v1 is the volume of sodium hydroxide in the first experiment, and V2 is the second volume, and V3 is the third volume. So now you have 3 volumes. You have to get the average of them. So to calculate the average volume of the hydrochloric acid added is V1 plus V2 plus V3 divided by 3. Then you get the volume per cubic centimeter. You will get the volume as cubic centimeter. So V cubic centimeter of hydrochloric acid is needed to neutralize 25 cubic centimeter of 1 mole of per cubic decimeter of sodium hydroxide solution. So that is the conclusion. The conclusion is you need the volume V cubic centimeter of hydrochloric acid to neutralize 25 cubic centimeter of 1 mole per cubic decimeter of sodium hydroxide solution. So the number of moles of solution of hydroxide. So now the number of moles of sodium hydroxide. So to get the number of mole is 0.1. As you can see, it's all given. 0.1 times 25, right, divide by 1000. You will get the mole, because you are required in mole, but you are given in centimeter. So naturally you have to convert them. So the number of moles of sodium hydroxide in mole will be 0.1 times 250 divided by 1000, right? Then you can write the equation NaOH equals plus HCl equals will react to produce HCl plus H2O liquid. HCl is the aqueous and H2O liquid. So from the equation you will see that 1 mole of NaOH neutralize 1 mole of HCl. It is straightforward, because 1 Na, 1 Cl, you know, and then 1 H and 1 OH. So NaOH, 1 sodium, 1 hydroxide, plus 1 hydrogen plus 1 chlorine. So they just change places. So they trade places, and you have HCl plus H2O. So from the equation, 1 mole of NaOH neutralize 1 mole of HCl. That is quite simple, right? Now in the reaction, 0.1 times 25.0 mole of NaOH neutralize 0.1 times 25 or 25.0 mole over 1000 mole of HCl. So when we talk about in 1 mole neutralize 1 mole of NaOH neutralize 1 mole of HCl. So in our calculation here, the amount is only 0.1 mole times 25. So you have to convert them into decimeter, cubic decimeter. Then instead of 1 mole, it is 0.1 mole of 25 times 25 of NaOH will neutralize 0.1 mole times 25 or 25.0 over 1000 of HCl. It means the same thing. The ratio is 1 to 1, right? So the molarity of the HCl is equal to 0.1 times 25.0 over 1000 mole divided by volume over 1000 cubic decimeter, right? Because when we talk about volume, it always has to be in cubic decimeter. Then we have to use that 1000. So what you have here is you will get 2.5 over volume mole per cubic decimeter. That is the formula. So the molarity of the HCl will be 0.5 times 25.0 over 1000 mole divided by volume per 1000 cubic decimeter. That will give you 2.5 over volume mole per cubic decimeter. So the conclusion is molarity of HCl is equal to 2.5 over volume mole per cubic decimeter. Don't get confused. This is very simple. It's just that you just look carefully at the figures to understand the relationship between the volume and the molarity. So to get the molarity, this is how you do it. Now do take note, number one, the relationship between the acid and the alkali that are reacted in an acid-base transition can be expressed using the following formula. MA times VA over MB times VB, which actually is equal to A over B, right? So what is A, what is B? So MA is the molarity of the acid, while MB is the molarity of the alkali. So MA over MB, you need MA to neutralize MB, so MA over B. So MA over MB will give you the neutralization effect. So MA is the molarity of the acid, whereas MB is the molarity of the alkali. Always remember that A is always acid, B is always alkali, and M stands for molarity. Now what about V? So VA is the volume of the acid, and VB is the volume of the alkali. So you have the molarity, you have the volume. So you have the molarity of the acid, you have the volume of the acid. You have the molarity of the alkali, you have the volume of the alkali. So this is what the whole thing is all about, right? So A is the number of moles of the acid shown in a balanced chemical equation. Always remember, A is the number of moles of acid shown in the balanced chemical equation. What about B? Obviously, it will show the alkali. B is the number of moles of alkali shown in the balanced chemical equation. So A is always the acid, B is always the alkali, and also A will tell you the number of moles, and B is the number of moles of alkali, right? So in the titration above, the chemical equation for the neutralization reaction is NaOH equals plus HCl equals will react to produce HCl and H2O. Okay, this is 1 to 1 again, right? So A is equal to 1, B is equal to 1. Now that is the number of moles. A, number of moles of acid is 1. B, number of moles of alkali is 1. Therefore, MA times V volume divided by 0.1 times 25.0 is equal to 1 over 1. So here the ratio is 1 over 1. So that's what the whole thing is all about. And if the volume is different, of course you get a different calculation, different answer. Therefore, the molarity of acid is equal to 0.1 times 25.0 over V, mole per cubic decimeter, which is equal to 2.5 over V mole per cubic decimeter. Now number 2, the pipe should first be cleaned and rinsed with a little sodium hydroxide before being used. This to ensure that there is no contamination in the pipe, what other stuff. That is to be accurate. And likewise, the bure should first be rinsed with a little acid before it's filled with the acid. You heard all that explosion? That is just all the Hari Raya, firework being played while we are doing this lesson. So I hope it's not a bother to you. So the bure should first be rinsed with a little acid before it is filled with the acid again, so that the bure will not be contaminated or adulterated or some other stuff. It need to be accurate. It need to be exactly what it should be. That is, if it's an acid, it should be an acid, nothing more, nothing less. So a piece of white tile is usually placed at the bottom of the conical flask before the addition of the acid, so that the color change which occurs during titration can be detected clearly. As I explained earlier. And then again, phenolphthalein can be replaced with methyl orange in the experiment. The color of this indicator from yellow when alkaline to orange when neutral. So it is different from pink to colorless for the phenolphthalein, and for the methyl orange it become from yellow to orange. Okay. So the endpoint of acid-base transition titration can be determined through pH meter or conductivity cell. There is another way you can determine the endpoint. Either you use pH meter or use conductivity cell, meaning when electricity stops flowing, meaning the titration is complete, no more ions. When ions are moving, electric current will flow. The moment the ion stops moving, meaning there are no more ions in the solution, that it means the solution is already neutralized and the pH is 7, right? So you can also use conductivity test to determine the endpoint of titration. And of course you can also use a pH meter, which is so convenient, right? So today we don't need to go and do the difficult things. You just get a pH meter, just dip into the probe into the solution, there, bango, you have your reading right away, right? To be precise, to be exact, it can be even 7.2, it can be even 7.3, it can be even 6.8, or it can be 6.9, and it can be exactly 7.0, whatever you need to do. So having this meter is more accurate. But those days we don't have all these meters, so we have to use some other form, and using all these indicators is just a good way of knowing the completion of the reaction. They're just as good enough then as now. So you will always encounter some numerical problem in your maths, in your test, in your chemistry test. You'll be required to calculate this and that, right? So here we're gonna do some calculation and see how it is being done. So number 1, you are asked to calculate the volume of 1.5 mole per cubic decimeter of hydrochloric acid that reacted completely with 16.2 grams of zinc oxide powder. What is the question? The question is calculate the volume. They want to know the volume of what? Of hydrochloric acid. For what? They want to know what is the volume of hydrochloric acid that will react completely with 16.2 gram of zinc oxide powder. Now listen, they give you the volume to calculate here is of 1.5 mole per cubic decimeter of the hydrochloric acid. So they want to know what is the volume of the number of hydrochloric acid that is required to react with the 16.2 grams of zinc oxide. So as usual, when you get things in grams of any substance, all you need to do is just get their relative atomic mass. Now zinc oxide powder, right? So you have the H as 1, O, oxygen is 16, Zn is 65. So the solution here will be, first, just write the equation. That's the first thing you need to identify. So zinc oxide, right, which is ZnO, which is solid. You know, you need to add to HCl. So here you have 2 HCl equals, why do you need 2? Well, there is a reason why you need 2. We just don't write 2 for the sake of writing 2, you know, because you know zinc has a 2 plus charge. So any metal out there, any ion that need a 2 plus charge will require 2 substance, you know, to balance them up. So here, since zinc has 2 charge, so now holding on to by the oxygen, so you want to replace the oxygen, you know. So zinc will need other stuff to hold on to be a salt. So zinc will need a chloride. So how many chloride will zinc require? Of course, zinc will require 2 chloride. Where to get 2 chloride? You have to get 2 hydrochloric acid molecule, then you have 2 chloride. So that's how you have to think how to do this equation. So now zinc chloride solid plus 2 HCl equals, will react to produce zinc chloride, zinc plus Cl2, right, plus H2O. So here you will calculate all the numbers. You know, you have the H1, H is 1, O is 16, Zn is 65. So now you look and calculate, you know, what are the numbers involved here. So the number of moles of zinc, right, you are given as 16.2, but what is the volume of zinc? What is the atomic mass of zinc? Zinc has 81, so this is only 16.2. So part of a mole of zinc. So so little amount. So the number of mole of zinc is equal to 16.2 over 81. 81 meaning the amount of mole is the amount of zinc in mole is 0.2 mole. So from the equation, 1 mole of zinc reacts with 2 moles of hydrochloric acid. You see, 1 zinc reacts with 2 hydrochloric acid. So 1, 2, 2. Therefore, if it's 0.2 mole of zinc oxide, you know, will react with 0.4 mole of HCl, which is twice the amount. Right? So the number of mole is 0.2 for zinc. So then you know the reaction needs 2 HCl, so the HCl should be twice as much as the zinc. Therefore, if zinc is 0.2 mole, therefore the HCl should be 0.4, which is twice the amount. So the volume of HCl is equal to 0.4 mole over 1.5 mole per cubic decimeter, meaning the volume of HCl is actually 0.267 cubic decimeter. 0.267 cubic decimeter. And how much is a 0.267 cubic decimeter? Well, it's actually 267 cubic centimeter. So now they want you to calculate the volume of the hydrochloric acid in that 1.5 mole per cubic decimeter. So actually it is the volume of HCl required to neutralize 16.2 gram of zinc oxide powder is 267 cubic centimeter. That is how much of HCl you require, or that can be neutralized by the zinc oxide. So here, that is how you calculate. Understand the question, calculate the volume of that hydrochloric acid that react completely with 16.2 grams of zinc oxide powder. So this is the way. Just go through and look at the numbers and try and digest the whole thing. It's quite simple actually, right? Number 2. Now 20 cubic centimeter of 0.1 mole per cubic decimeter of sulfuric acid is neutralized completely by 25 cubic centimeter of aqueous potassium hydroxide solution. Now they want to calculate the concentration of the potassium hydroxide in mole per cubic decimeter. So they have given you the sulfuric acid is 20 cubic centimeter. They want to know, the concentration of the potassium hydroxide, which form the 25 cubic centimeter of aqueous potassium hydroxide solution. So what is the concentration of that potassium hydroxide? So now when you look at this 20 cubic centimeter against 25 cubic centimeter, it's not the same, it's not 1 to 1, right? So here is the trick. So here, first thing you have to write the equation. So sulfuric acid H2SO4 equals plus 2 KOH equals will produce K2SO4 plus 2 H2O. Again, why do we need 2 KOH? Why not only 1 KOH? Simply because the H2SO4 or the sulfuric acid, have 2 hydrogens there, right? So if you want to neutralize the hydrogen in order to convert this acid into salt, right? So you need 2 K to take over the SO4. So that's the reason why you need 2 KOH. Only having 2 KOH will 2 potassium will get attached to the sulfur, right? And then of course, see, you have 2K, you have 2 H2Os, right? Now B is equal to 2, A is equal to 1. What is B and what is A? Don't remember B? Volume. A, B is volume of alkali, A is volume of acid. Look, H2SO4 is 1 molecule. That means 1 molecule of acid, or 1 mole of acid. Now you have 2 KOH, so you have 2 alkali here, therefore the alkali B is equal to 2. That's what B is equal to 2, A is equal to 1 means. Okay, and you have the VA, which is 20 cubic centimeter, and you have the MA at 0.1 mole per cubic decimeter. The molarity of acid is 0.1 mole per cubic decimeter, right? And then you have the volume of B, volume of the alkali at 25 cubic centimeter. So what do you require? You have the MA, but you don't have the MB. You have the VA, you have the VB, you have the MA, but you don't have the MB. So we are looking for the MB. What is the molarity of the alkali? So concentration of the potassium hydroxide solution, that is the MB, is B over A times MA times VA over VB. So B is 2, A is 1. What is MA? MA is 0.1 mole. What is VA? Is 20. And what is VB? 25. So you just plug in the numbers, you'll get 2 times 0.1 times 20 divided by 25. So your answer is 0.16 mole per cubic decimeter. That is how much you require. That is the molarity of the or the concentration of the potassium hydroxide needed to neutralize this 20 cubic centimeter of sulfuric acid per 0.1 mole per cubic decimeter. That's what the whole thing is all about. Okay, I hope this is not confusing at all. Yeah. So finally, let's look at another solution. 60 cubic centimeter of 0.1 mole per cubic decimeter aqueous sodium hydroxide is neutralized completely by 10 or 0.0 cubic centimeter of 0.2 mole per cubic decimeter acid W. So what is the basicity of the acid W? Oh, now they want the basicity. Alright, so here read the question again. 60 cubic centimeter of 0.1 mole of aqueous sodium hydroxide is neutralized completely by 10 cubic centimeter of 0.2 mole of cubic decimeter of acid W. So here look at the figure. One is 60 centimeter cubic centimeter, the other is 10 cubic centimeter. Whether the other hydroxide solution is 0.1 mole, whereas the acid is 0.2 mole. You look at the numbers. So offhand you can see that 60 over 10 is 6 times, but then it's 0.1 mole over 0.2 mole. Meaning you have to divide this by 2. So offhand you know that for 60 cubic centimeter of 1 mole is equivalent to 30 cubic centimeter of 0.2 mole. It's the same. So offhand you know that this acid W surely have basicity of 3 times, right? So let's check. So number of moles of NaOH is 0.1 times 60 divided by 1000, right? What is the number of NaOH? 0.1 mole times 60 centimeter over 1000. That is very clear. So the number of moles of acid W is 0.2. 0.2 times 10 over 1000. Aha. So what does it mean? 0.1 times 60 over 1000 mole of NaOH neutralizes 0.2 times 10 over 1000 mole of acid W. That's what it says. All they want to know is they want to know the basicity. They have given you, they let you know that 0.1 times 60 moles of NaOH, right, will neutralize 0.2 times 10 over 1000 mole of acid W, which if you convert them into decimals, you'll find that 0.006 mole of NaOH also neutralize 0.002 mole of acid W. So 3 moles of NaOH neutralizes 1 mole of acid W. 3 moles of NaOH neutralize 1 mole of acid W. Therefore, the basicity of acid W is equal to 3. So, acid W is a triprotic acid. Can you name a triprotic acid? If you recall, yes, phosphoric acid. Alright. So, guys, that is the lesson on neutralization. So that covers our chapter on acid and bases, and our next lesson will concentrate on salts, and this is another interesting subject that we ought to learn and apply in our life, right? Until we meet again next week, this is Teacher Medza saying, enjoy your Hari Raya and enjoy your open house, but make sure whatever you eat moderately, but most important thing, you better balance whatever you eat with some fruits or vegetables, and of course take plenty of plain water. That definitely will help you, and you will not encounter any stomach ache or diarrhea or whatnot. So until then, we'll see you again. This is Teacher Medza bidding you goodbye, and see you again next week.